guys, welcome back to my channel. I hope you guys are doing well. So if you are new to my channel, my name is Arnabi Mitra and I'm working at Amazon as SD. So this video is the continuation of my binary search series, and I have already published my first video on explaining the basic binary search, and from now I will be explaining the binary search questions, which are application of binary search, or where we can apply this kind of log n algorithm, like we need to divide the array or string or whatever our search space into two hubs. Like we have some points like the array should be sorted or our search space should be in sorted order, and how we can apply this particular approach, like dividing our search space into two hubs and for each iteration going for one hub. So without wasting any time, let's check what is today's problem. So today we will be talking about, uh, so we have one array and we need to find the same way, we need to find one element in one array, but here we don't have, we have the array as sorted but rotated sorted array. So let me write the question. We are given one rotated sorted array, and we need to find the element from there. For example, we have an array like this: 3, 4, 7, 8, 10, 12, and we need to find this 8. Now we know this array is sorted and we can apply the binary search to find this 8. But suppose the array is like this. It's rotated like 8, 10, 12, 3, 4, 7. So it's rotated for 3 times and 8 has come at beginning. And when we try to apply binary search, for example, the mid will come here, and when it will find that, oh, there is 12. Okay, just forgot, we need to find 8. We need to find this 3, okay. And mid will come at 12, and when we will check, we need 3, we will think that 12 is greater than 3, so our search space should be at left side, and we will come at left, and at left there is no 3, and we will return that element is not found. But that is not true. 3 is there. So because it is an rotated sorted array, the 3 is there. Now how we can solve it and what should be our approach, I will be explaining. So let me take the same example here only. 8, 10, 12, 3, 4, 7. 8, 10, 12, 3, 4, 7. Now here are something that we should notice. For example, we are at 12, okay, and we can see this 12 has two parts, or maybe let me rotate this array some more, like 7, 8, 10, 12, 3, 4. Now our midpoint will be here. Now we can see two things. So at left we have this 7, 8, 10, and at right we have this 12, 3, 4. Now there are some observation. What is that? This left part is sorted. 7, 8, 10 is sorted, but the right part is not sorted. So from here, can we say that, okay, if somehow we are able to identify that there is one part that is sorted, and then if we try to apply binary search, will that work? So the question will be, is there always one side that is obviously sorted? So for that I will take each and every iteration, I will show you if yes, that is possible. So let me write here like this: 8, 10, 12. Now rotate, I will just rotate 1, 3, 4, 7, 8, 10. Now our mid will come here, and you can see this part is sorted, not this. Again, if we rotate like this: 10, 12, 3, 4, 7, 8. Now we can see this part is not sorted, but this is sorted part. The next thing is here only. This is sorted, but this is also sorted. So there is always one case that two part is sorted. Again, if we move a little more, for example, this, so left part is sorted, right is not sorted. Yeah, so whenever we are at any point, either right part will be sorted or left part will be sorted. Now the question is it that our element is always in the sorted part? Obviously no. For example, here in this particular case we can see this part is sorted 7, 8, 10, but this 12, 3, 4 is not sorted. So if we are searching 8, if we are searching 8, we can easily say so the left part is sorted and 8 is inside that range, and go and find 8 and just apply the binary search. But suppose if we are searching for 3, we cannot say that go and search, go and apply binary search. So what we will do, first we will try to find the sorted portion, and if our element is inside that, for example, if we are searching for one element and we got one sorted part, and our target element belongs to that sorted part, we can say okay, go and check into that range, and our range will be that particular range. But if our target element is not inside the sorted one, then we can conclude either it is on the other part or it's not existing. The same way, so we have now kind of four cases, uh, not four, 5 cases. What is that? Mid equals our target. So if mid is target, no need to worry, we will simply return. This is the first case. Now the second case, what is? Left side is sorted. If our left side is sorted, we have two sub cases, that inside sorted range our element is there, or the next sub case will be it's not in that range. Now the third case is right side is sorted. So obviously if left is not sorted, it's guaranteed that right will be sorted, and again these two sub case will be there, either in that range or it's not there. So now we will think like what should we do. So let me write here. So if mid value is target, we will simply return that index or true something. If left part sorted, how we will check left part is sorted or not? We will check the start index value and mid value. If mid value is greater than start, because we are saying that there is no repetition, it's kind of sorted and it's not repetition. So if that start is less than mid, then we can conclude that that part is sorted. So if we check the example here, 7 is less than 10, that's because this part is sorted. If not, for example, if we come here mid is 4 and start is 12, 12 is not less than 4, so that means this part is not sorted. So whatever the part will be, the first kind of value will be greater than next. Like here 12 is not less than 4, but this part 4 is less than 10, so this part is sorted. So if left part is sorted, and the first case like in range, our target in range of that, then what we can do, we can make our like range as start to mid minus 1. If not in the range, left part is sorted but our target is not in the left range, then obviously either it's in right part or not present. So we will make like our range will be like mid plus 1 to end. And if right part is sorted, same way the first condition, if in range, then our search space will be mid plus 1 to end. So both the cases our search space are same, but the way we are looking are different. Again, if not in the range, obviously it will be in the left part, so our range will be start to mid minus 1. So anyway, we have three cases and two subcases of this sorted one. And anyway, in each case, we can divide the array into two parts. So yes, we can say that it's an log n algorithm and we can apply binary search successfully. Now, I hope you have understood what we are saying. Now, I will quickly check and take an example and I will explain. So, for example, let me take the same old example here and I am writing randomly 12, 3, 4, 7 and we need this 7 to find. So, we will first come to the middle 12 and we will check for the sorted part. We can say this part is sorted. Anyway, this part is also sorted, but first I am checking this part and we are checking, okay, this is sorted and 7 is not inside, so our range will be now 3 4 7. We will come here, 4 is our mid. We can say anyway both the part is sorted, but we will always check for left first. So this is left, 7 is not in this range, we will go to right and we have only one and 7 and we found it. Let me take another example and let me make the array like this. And now suppose we need 8. Okay, not 8, let's suppose 10. So our mid is 3 and we can say that this part is not sorted, but this part is sorted. 3 to 8 is sorted. But 12 is not in this range, so our range will be 10 to 12. Now 10 to 12, 10 is the mid and there is nothing in left, and at right there is only one element and 12 is present there and we are able to find it. Let me take another example very quickly. Suppose we are looking for the 4. So in that case again 3, okay, let me write 3 4 7 8. We are looking for the 4. Our mid is 3. We found this part is sorted and 4 belongs to this range. So our search space will be like this. Now our mid value is 4 and we got 4. So this is our answer. So like this we can say that our binary search login approach is working. And I will quickly show you the code, the Leetcode code link I will be giving you in comment section, and the code solution which I have written also I will tell you. So here is my code. I have given Java and C++ both the approach, you can check. So I will explain quickly. We have this low and high that I have taken, and obviously our while loop condition will be low is less than high. So it's same as the binary search. If you haven't checked my previous video, I will suggest go and check the first video to understand the binary search properly and then come to this video. Same way we are taking the value of mid, we are checking if mid is target, we will return true. Else if mid is greater than equals to left, equals I am saying because there can be only one number. Is there are some cases where low is itself mid, there can be only one number, like so suppose we are at one number, so in that case low mid high all the values are same only. So that's why I am just saying this for the safety. And we will check if the target is inside this range. The target is greater than equals low and less than mid, so the target can be equal to low. So that's why I have taken this equals. And why I haven't taken this equals, because at first only we are checking if the value is equals to mid. So if we are coming in the else if loop, that means the target is not equals to the mid value, so there no point of giving equal sign here. So if it's in the sorted order, then I will make the range from low to mid minus 1, else our range will be mid plus 1 to high. Else if left is not sorted, then obviously right part will be sorted. And we will again check if the value is greater than mid and less than equals high. If yes, then our range will be mid plus 1 to end, the same range here. Else our range will be low to mid minus 1, and if we are not able to find, we will return minus 1. And this question actually asking for the index where the element is found, so every time I am returning mid, like where the found, else I will return minus 1. The same way C++1, both code looks exactly same, only the size. Here I have mentioned size and here I have mentioned length to take the value. So I hope you have understood. this part, and I have explained it. So this is one of the applications of binary search. Even if the sorted array is rotated, still we can apply binary search to find our element. So this is the question. If you like it, please like, share, and subscribe to my channel. If you want to connect with me, you can connect in TopMet. I am taking 1:1 call, mock interviews, and also I would suggest, if you have any feedback, let me know in the comment section. You can join me in Telegram and LinkedIn. All the links are in the description. Thank you.